Hello and welcome back. Today we're going to start Chapter 3, Part 1. This is Measures of Center. We have a few definitions to get through, and we will start with a measure of center. It's valued at the center or middle of a data set. Now there's actually quite a few different ways that we can find a measure of center and what we mean by that. The first one is the most important one. That is the mean. The mean is the most important of all numeric measurements used to describe data. It is what most important people call an average. And I didn't mean important people. If the data are a sample from a population, then the mean is denoted by, again, the key here is sample, then we use X bar. I mentioned this in a previous video. If the data are the entire population, the mean is denoted by, and I'm going to write this over here, this is a Greek letter M called a mu. We often use Greek letters for population measurements. And we're going to go ahead and practice. This is for the mean. And the way we find the mean, just in general, X bar, we're going to learn a new notation here. And this is the sum of the data. So this is a Greek capital letter S called a sigma. It means add up all of the data. N is the number of data. So for example, N here is 1, 2, 3, 4, 5. The X's that I'm adding up are going to be these. So that gives me, I'm going to add up 22 plus 22 plus 26 plus 24 plus 23, and I'm going to divide that by 5. So the mean here, so X bar here, is 23.4. The next one, I could add them all up and divide, in this case, by 7, I believe. 1, 2, 3, 4, 5, 6, 7. So 22 plus 22 plus 26 plus 26 plus 24 plus 23 plus 23. Then I divide that by 7 because there's 7 data here. Divided by 7. So that's going to be X bar. And I'm using the approximately equal to symbol. You'll see that throughout the semester. This just means I have to round it off somewhere. And it looks like it's 23.7. And you should be verifying each of these. You shouldn't just be watching me do it. You should have a calculator and actually be working it out. Pause the recording if you need to. And then we could do the same with this. In fact, I'll leave that to you to work out. Next up, we have a different measure of center called the median. And this is literally the middle, but all the numbers have to be in order, and you'll see this is not in order. So this is 22, 22, 23, 24, 26. So you have to rewrite it in order. And here's how we do this. We literally find the middle number. So I'm outside, I'm going to go in, and then go in. Here's my middle number. So in this case, 23 is the median. For this data set, add 25 as another data set. I want to show you what happens when we get this. So I'm going to put this in order. Let's see, 22, 22, 23, 23, 24, 25, that's the one I added here. 26, 26. 1, 2, 3, 4, 5, 6, 7, 8. And that's 7 and 8. Okay, so now we're going to go find the middle number. by doing this. I'm out here, I'm going to go to the middle, one more in, one more in. Now here's where it's a little bit different. I have two middle numbers in this case. That's okay. What I'm going to do is I'm going to find the mean of these two. So I'm going to go 23 plus 24 divided by 2. So this is going to give me 23 and a half. There's a dot in there somewhere. So that's when it's an even number and you have 2 in the middle, you have to find the mean of the middle 2. And I'll let you do that one on your own. Next up, we have the mode. This is the most frequent number, meaning the number, let's move that up, the number that comes up most often. So we can see 22 is the mode there, because there's 2 of them. Here we have a couple of modes. We have 22, 23, and 26. So in this case, it's trimodal, meaning we have 3 modes. And when nothing's repeated, we just say no mode. That's textbook specific. Some textbooks would say that they are all the mode because they're there, but your textbook says that it is no mode. Next up, we have mid-range. That is the maximum plus the minimum divided by 2. So that's literally the mean of the largest and smallest numbers. So let's do one right here. So you can see the largest is 26, 26 plus the smallest, which is 22, divided by 2. 26 plus 22. That gives us 24. Okay, so this last part is the part that's going to take a bit of time. So when we have a frequency distribution table like this, and we don't have the raw data, we can approximate the mean is going to be the summation of the midpoint times the frequency. So f times x, all divided by the summation of just the frequency. This is too small for me to write in, so I actually, my wife rewrote this for me so I can use it. Of course, it looks absolutely beautiful compared to my handwriting. So in this case, I'm going to go ahead and write the frequency in. 2, 33, 35. You may recognize this data. This is from those IQ scores that we were using in previous lectures. And I'm going to start with the summation. Remember that that's a sigma. That means I'm adding them up of the frequency. So this becomes 2 plus 33 plus 35 plus 7 plus 1. 78. To find the class midpoint, we did this in an earlier video, so I'm not going to spend a lot of time, but I'm going to take the 50 plus the 69 and divide by 2. Again, we're finding the mean. 50 plus 69 equals divided by 2. You should also, again, be doing this with your calculator yourself, not just watching me do it. And using the same process, get this. Once again, I want to point out this summation of f is the denominator here. What we're going to do next is we're going to multiply f times the midpoint. So this becomes 2 times 59.5. $33 times 79.5. Once again, you should be doing these with me. If you need to pause it, if I'm going too fast for you, then pause it, but you should be doing this yourself. We have 35 times 99.5. Seven times 119.5. And lastly, 1 times 139.5. I know 1 times anything is itself. And what I'm going to do is I'm going to add all that up. And I need you to verify this. It's going to give me that there. You double check me. You add those up yourself. And make sure I multiplied correctly. All right. According to the formula, I'm going to take this number and divide it by this number here. So x bar is approximately equal to... Approximately is because we don't have the raw data, so we don't know exactly what the mean is. We're just doing the best with what we have. 7201 divided by 78. 7201 divided by 78. This is, again, I'm rounding off, so it's approximately equal to 92.32, it looks like to me. And that makes sense. It's right in this around here. Notice most of the data is here, so it makes sense that 92.32 is the mean for this. Again, the approximated mean for this. All right.